Welcome! In this video, we are going to look at problem 17. It is from chapter 22 of college physics by OpenStax. Okay, so we have a velocity selector that's in a mass spectrometer. We know the magnetic field. We need to find the electric field strength, so that implies magnitude of electric field. And then we know our speed that we want is 4 times 10 to the 6 meters per second. And then in part B, we need to find the voltage given a plate separation. Okay, so we have some key equations. The velocity is the electric field divided by the magnetic field. Okay, that one comes from equating the electric force and magnetic force. So Fe is equal to Fb. Okay, and so Fe is Q times E. Fb is QVB, and then we're going to have the velocity and magnetic field perpendicular to each other, so we have sine 90. Okay. We can get rid of a Q on both sides. Electric field is velocity times magnetic field, and the sine of 90 is 1. Okay, so velocity is electric field divided by magnetic field. All right, so for our problem, let's write down what we know. We know the magnetic field is 0.100 Teslas. We know the velocity is 4.00 times 10 to the 6 meters per second. Okay, and then we will have a distance of 1 centimeter. That value will need to be converted to meters. Okay, we would like to find the electric field and the potential difference or voltage. Okay, so for part A, we can use V is E divided by B. We want E, so multiply both sides by B, and we get E is velocity times magnetic field. Okay, so the velocity is the 4.00 times 10 to the 6 meters per second times the 0.100 Teslas. This gives us an electric field of 4.00 times 10 to the 5th, and then we will have newtons per coulomb. Okay, so that's part A. Part B, we want the voltage between the plates, and we're going to use voltage is ED. Note, we're not using the minus sign since we're looking for the magnitude of electric field. Well, we found the magnitude of electric field. We're looking for voltage. Okay, so voltage is going to be the 4 times 10 to the 5th newtons per coulomb times the 1 centimeter that we need to convert. We're going to change the C into a times 10 to the minus 2 meters. This is going to give us a voltage of 4.00 times 10 cubed volts. And we can write out the word volts so that isn't confusing. But that is that problem. I hope you found that informative and that it helped, and I will see you in the next one.